So we're here at other ways to attack users, and the first and most important one is request forgery. So this is where you, now it's related to session hijacking, but this is where you do not steal the token, you trick someone else into making a request from their authenticated session. So you don't need to steal their password, you don't need to steal your token, but you do need some way to add code to a page they view. So let's take a look at on-site request forgery, which is a simple case. I think it's a very useful term because cross-site request forgery is a famous one you hear of, but here's a simpler version of it, on-site request forgery. So I have a message board. This is the example straight from the book. I just coded it, and it's good, clean fun to have it ready to go. So let me refresh this page and get the default value. So I have a message board, and you can post various things on the message board. You can post a type of thing, like I'll post a question from Max saying how to hack this. So when you submit it, you get this. You get an image, you get 3 items, an image, the name, and how to hack this. And if you look at the source code of this, what it does is this stuff is all hard-coded. From here and here, that's all hard-coded by the developer, and these 3 things came from the user without sanitization, or at least without obvious sanitization. So the user input appeared here as part of this name of the image. Here is the name of the person, and here is the comment. So you can try various kinds of injection here, and what I usually do when I'm looking for cross-site scripting is I just put in a italic thing just to have something. So let's try that. If I put in an italic and say a 1, I'm not even going to bother closing it, because if it works, some portion of the page will become italic. And let's see what that does. And the answer is nothing becomes italic. And you can see here the greater than, less than signs just sit there, which means they've been URL encoded, and you'll be able to see that if you view the source. And this is, so this page contains anti-cross-site scripting filtering that removes less than and greater than signs and turns them into these things, which do not run code. So I cannot insert a script tag, and I can't insert a lot of things. The typical kind of cross-site scripting is not going to work. But I did manage to break this image. So let's see what happened there. I got this thing turned into a GT inside the image, the italic. So I can change the name of the image. And now, as you remember, we've been through this a lot of times. I can now put a quote. Now, if I could put in a quote and a greater than sign, I could close this and add another tag, but I can't put in the greater than sign. So I can't do that either, but what I can do is I can just adjust that path. It is going to send an HTTP request to fetch this object, and I have some control over this object. So I can get somewhere if I can get there by just changing the middle of the URL and point to something useful. And it turns out that this works because this is being stored, and this board can be viewed by other people. So I can save this and let people view it, and sooner or later an administrator will view it, so I can then execute administrative actions on here, and that's what I do. So here's the injection from your book that works just fine. You put that in for the question, and what this does is it does .. to move back up from the images directory, then it goes to a function that makes a new user, and then it feeds in the parameters for the new function, and then it ends with a # to comment out the rest of the line. Otherwise, I will have a .png at the end, and I'll foul everything up. So that thing has the result of creating a new user, and I made it so it pops up and tells you new user called with new user created DAF2. And then if you go here, you can see the results. And so it took effect before I could see the page, which is what happens while it's trying to load the page. It takes effect. And so here's what it does. Images, then back up, then run new user, then put in those parameters. And so this will happen as soon as anybody views the page and attempts to create a new user with their account. And normal users, it won't work, and they might see an error message, or more likely they'll just see nothing. Because here's another fun fact about the same origin policy. This is in fact going to the same server, so it doesn't apply, but this is another fun fact from this chapter. You can make a request to another server. Of course you can, right? You're a browser, you're the client. you can send data from like samsclass.info to Facebook, and it will go, but you can't process the response on a page named samsclass.info. So you can send things like this that might create a new user. You won't see the result. And if you do the pen testing lab projects we've been doing in 140 class, they're mostly this way. When you're doing injection attacks and running code on a server, you typically get like a 500 error. You usually can't see the results because it's returning something in the command line of the terminal window which is not visible to the browser and doesn't come back to you. But it's working. So anyway, this one works, creates the new user, and if I wrote the code so it'll pop up something so you can tell that happened. But normally you wouldn't be able to see that it worked. So that's on-site request forgery. And this is what Sammy Kamkar did to MySpace. He put something up which would then cause other MySpace users to take an action on MySpace. There was nothing cross-site about it. All right. So when you have a stored vulnerability where you can store something that many people will see, and you have to be able to store something active there, which doesn't have to be script tags or JavaScript. Here it was just a URL. But you have to be able to modify the code that people see somehow. So here, you put that kind of thing in the name of the image, and that turns the browser's action of rendering the image into a request that creates a new user. This is, it's the lesson of this whole course is that you can abuse things for unexpected purposes. And anyway, it seems to me like if I wanted to stop this stuff, it seems to me like I could code a browser that knew when it was fetching an image and refused to do other things, but probably you can't because they keep inventing new ways to fetch images and host images and stuff, and dynamically generate them and stuff. It might be that some bizarre request is what actually ends up in an image, I guess. I was thinking about this as I read this stuff, and there was a talk last night from one of the students about the flaws in JavaScript and Python. It was just horrifying, where you could just create objects and then like we create A and B, and A equals B is true, but B equals A is false, and just horrible things like that. Because these languages are weakly typed. And I'm thinking, we should, back in the days of C, you just knew exactly what was happening to the bits with every command you executed. And if you use these high-level loose languages like PHP and JavaScript and Python, they guess what you're trying to say, like someone that doesn't really speak your language. And so you put integer equals string, and it just decides to turn one of them into a string or the other one into an integer at its own discretion, and then decide what result is going to be, instead of bothering you with an error message, which I would much rather get. That's why I know Perl had a strict version to avoid this. Anyway, I'm just thinking I would like to see strict JavaScript and strict PHP that would just never do that. Yeah. Anyway, so if you want to prevent this stuff, you can, of course, validate user input. Filtering out more special characters might help. If you'd filtered out the .. that would have had made the last one a little more difficult. The previous one, it was the type that I was putting in, like picture. And there really are only a certain number of values there anyway, because it's trying to put a picture on the page. You really shouldn't be letting the user type in the name. You should make them choose from a list of known values. But of course, even if you did that, they could just change it in burp on the way out. What they really ought to be doing is sending up like an integer of which of the 4 values you want, and only accepting those 4 values. And as we saw, HTML encoding will not stop this attack because it'll be interpreted as HTML at the other end, and it'll still be interpreted as a meta character in the path. So the next step is cross-site request forgery, where you create a website that causes your browser to send a request to the vulnerable application to perform some activity. So you visit my blog, you view my image, and now you've bought my book at Amazon. This, of course, relies on the fact that you do have an authenticated session with Amazon, but most people are logged into a bunch of stuff all day long. Amazon, Gmail, Facebook, they have tabs open. So a cross-site request forgery going to one of those sites will work. There is a cookie available. And what we're doing here, of course, is abusing cookie authentication. Your browser sends the cookie automatically with every request to the domain, so everything you do is being authenticated automatically without you knowing it or caring. So anyway, like I said, this is the one I said before. You can send requests to a different domain from the first domain because you might put an image or something from another domain on your page, and that's not forbidden. Okay, so they're one way. So you cannot do multiple stages. Like if you have a order form with step 1, step 2, step 3, and the defense is to put hidden fields on it, which are anti-CSRF defenses. There'll be a hidden field on page 1, which is random, which has to be included in your response to it to give you page 2. And you don't get that with cross-origin attacks. You have to actually be on the right domain, rendering the page in a browser, seeing it. And that's one of the benefits of anti-CSRF tokens. So you make a new account with this thing, going to new user, step 2, and putting in real name, username, and role, and password, and so on. That one post request will make a new account. So if a request performs a privileged action, and it takes your cookie as all the authentication required, then that means I can trick you with a request from another domain, and it will have effect. So here's a cute one. You can make a page like this, and this page is an HTML document with a form, and the form has hidden fields that do everything, and it has a JavaScript command here which does document form submit. So as soon as it loads, it submits the page. You don't click anything. It's like that image tag. Just viewing the page, you've now sent a request to the server, which is a post request with all these parameters filled in. So now you have created a user account with that name and password and all that jazz. So that happened to eBay. You can make a URL that would bid on an item from a third-party website. You could call the external website from an image tag. So simply viewing the item and seeing the picture would make a bid on it. Very much like the Sammy worm, where viewing the page, you would add him to your friends and put a copy of the image on your page, or copy the code on your page, so all of your friends will keep adding his friends. So, all right, that's the problem, because the cookie is automatically sent. This is in general true of all single sign-on systems. And I think in a more general sense, you can do it with Microsoft systems, where you make a connection to a shared server. This is what quite a few hacking tools do. They put up fake SMB servers, and they harvest SMB requests. So, and you can sometimes pump things like an image tag out in JavaScript to get them to go to a local resource, and then they will send their Microsoft single sign-on token, which is a hash of their password, up to the local server. And that's one way you pump out, that's where you pump hashes off the network. This is why Microsoft, which has been very, very slow to improve their cryptography for these things, actually did make some improvement for the network transmissions that are used for authentication, because they're so easy to steal. But they're still a million times weaker than Linux ones. So your web interface, your DSL router, most people have a default password, which they don't change. So your web page can log in with default credentials and get a session token and then do something. So I could just use cross-site request forgery to change the status of your router if you don't have something like a password blocking me. And you could also use DNS rebinding to do that. Another trick Vincent Taviso would use, where I change the meaning of my domain name to point to 127.0.0.1 or something else on your local network to change your router. So if you want to prevent these things, you're going to have to try something more than a cookie. And like I said, a typical simple solution, which is equally automatic for real users, is to have a hidden field in the form that they load, so that when they click submit, I get another field at the server, so I know that somebody actually viewed this page in a browser and clicked submit. It's not just a request generated by one of these tricks. And that's the game. This is what Cloudflare does. When you're under attack, a very common trick, and one that Cloudflare employs, is to just put JavaScript at the top of your page, which must render in order for you to be accepted as a legitimate request. So you ask for a page, they don't give you the page. They give you a little JavaScript to run, which will then send another request. And this will tell me if you are like a DDoS attacker sending a million HTTP posts and not looking at the response, or if you are a real user with a browser that will run the JavaScript and request the next thing. It's a brief delay for normal users, but it makes it easy to withstand a very large attack. It's a very common trick. And I've seen this code frequently in my Cloudflare pages, a little bit of JavaScript at the top. It's the same kind of thing. So of course the token have to change, they can't be predictable, and they have to be tied to the session. So you can't copy a token from one session and use it in another session, of course, and then they will prevent people from using any kind of automated attack, other than automating a browser. All right, then, if you send the token in the URL query string, then users can generate guesses for the request, including the token, and determine if that link has been visited. This is a trick that hit the web about 6 years ago. I saw everyone getting all upset. They said, I can see what sites you've been going to. You go to a page and it would have a list of like all the websites you've been to, because they use CSS to change the color of visited links. And what's not obvious to the viewer is that does not go to the server. It's in your browser. Your browser changes the color of a link that you've been to as opposed to a link you haven't been to. So I can write a page that has like 1,000 websites on it, and it'll only be visible if it's visited on your machine. So it looks like I know your browser history. I don't know it, but that's what this does. You can, if you use JavaScript, I can actually now query your browser and say, what color is that link on your page? Tell me. So I can pump out stuff. Now so you could pump out information about the token in principle. But it's a brute force attack, so if your token is long, it would be hard to guess, although I wonder if you could be smart and guess one digit at a time and use wildcard matches or something. I don't think so, but it would be interesting to see. Anyway, all right, so an anti-CSRF token will prevent a simple cross-site scripting attack like this, where I try to go to some forum and show an image and I try to put the file name for the image going to another server. Because if I try to go from forum to Amazon, the buy page at Amazon will get a request, but it will not have the hidden field. So it will not generate as a valid request. That's the idea. All right, so you can defeat these things by XSS. Then next, if I want to defeat the page with anti-CSRF protections, I need to use cross-site scripting to steal the anti-CSRF token from you. And that can be done. So, under certain conditions. But of course, that's the whole point. That's what all defenses ever do, is raise the bar. Okay, which attack requires stored cross-site scripting vaults? Okay, that's on-site request forgery. You have to store it so various people can view it, hoping the administrator will view it. All right, which method of authentication causes CSRF faults? That's right. Problem with cookies is they're automatically sent with every request. All right, so what will prevent CSRF attacks? Okay, the hidden field is what you use as an anti-CSRF token. That makes it so you can tell that a real viewer has really viewed the page. And it's not some kind of request forged from some other location. All right, what was the Sammy worm? The MySpace attack. Okay, that was on-site request forgery. He put it on MySpace and it affected what people happened to their accounts on MySpace. So UI redress, this is the famous cookie, tab napping, click jacking, key napping. There are many versions of it. Click jacking is the way it originally became famous. This is kind of amazing. And here's how it works, is because of cross-site scripting, and it still works. You put two pages, one on top of the other, and you put the one on top to be invisible. So you see one thing, but you're clicking on something else. So here it is in all of its glory. Here it is, UI redress. Okay, so here's the two things I have. I have a good button where you win an iPad and it says you win a free iPad. And I have a bad button that says you get hosed. And the trick is to make people think they're clicking on this one, but they're really clicking on that one. So here I put them in separate frames, you can see them. And this is the source code that draws the bad button. It's drawing from a different page. This is UI.html. It's drawing from another page called evil.html and putting it in an iframe. And that could just as easily come from another domain, and that's the target. This would be something like Facebook or Google, where I'm trying to trick you to click on Facebook or Google when you think you're clicking on my page, winning money or something. So here's a harder choice. Let me shrink this a little so it fits there. Okay, so now I've superimposed two things. You're seeing win an iPad, and you can see a little bit of the other button on top of it here, especially if I zoom it in, I can see a sort of shadow there. I put the two things together, and here's how it looks. I create, in my cascading style sheet at the start of it, I create a iframe type FG10, then I make an iframe ID equals FG10 with the source from there, and it draws from here the position to put it, and this is the important thing, opacity, 0.1. Opacity 1 is opaque, that's the normal condition. Opacity 0.1 means it's only 10% visible, so it just appears as a little shadow on top of that one. But that's the one you're actually clicking on. I click on what looks like Win an iPad, I get your hosed. But I've clicked on the almost invisible thing on top. And here's the one that's impossible. This is the one with opacity of 0. There is no clue at all. You're clicking on this and you're getting unhosed. So it's pretty impressive, and this is why Microsoft has this thing called the Secure Desktop ever since Windows Vista. When it's time to approve elevation to administrator, the screen goes dark and this one box pops up saying, do you want to elevate to administrator? Click continue. And in order to stop this kind of nonsense, it freezes every process, and the only process allowed to do that is the elevation process inside the operating system and the mouse and the keyboard. Nothing else is allowed to put anything on the screen during this process, for that reason. Because it's pretty, and then of course, Microsoft was guilty when Windows 10 came out of doing the old malware trick where they pop up a box. Do you want to install Windows 10? Yes or no? And whichever one you click, they interpret it as yes. Yeah. It's easy to code pages like that. It's just the kind of thing that you don't expect legitimate businesses like Microsoft to be doing. And people really yelled about that. Yeah. And they sort of apologized. But they're still ramming these horrible updates down your throat. Anyway, so that's the joy of clickjacking. And there are many other versions. There's versions where you type into you click on a field and you type in a message and it's stealing those key presses and putting them in another window and slowly spelling out a command like format C or whatever with the letters you type. There's many ways to go on with this UI redress where I trick your actions into going somewhere different than you think they're going. So you do it with keystrokes. I can trick you into filling in a CAPTCHA. I can have enter characters and have you approving things, clicking on buttons that you don't think you're clicking on, and on it goes. I can steal mouse movements. When you're dragging things around, you can be dragging something else you don't know about around. All right, I can therefore steal URLs, and I can steal anti-CSRF tokens. With this kind of motion, you could be dragging something to play a game, and what you don't know is you're highlighting the token, copying the clipboard, sending it to me. Yeah, it could get you to do it. If I convince you to play a fun game where you're dragging things around on the screen, you could be doing that.
Are there many websites these days of like prohibiting iframes though?
No, I'm doing it right here. No, the browser is still doing it. And I don't think, now there is a defense. You can put a special header on your web page to stop this. Yeah. But I doubt anybody's doing it. Most of these header-based defenses are quite strong, but the ones I've seen are related to HTTPS. And those show that developers are sort of lost in the soup. In fact, they developed like 3 different HTTPS defenses, pushed them for like 5 years, then they deprecated one, and what's happening is people are slowly starting to use the deprecated one. It's like when I was a kid, the movies were always 5 years out of date in my hometown. It's like everything developers do is like in a time machine, whatever we were telling them to do 5 years ago. They're just getting around to that. So in 5 years, they're going to notice we told them to quit doing this. They're not going to get to doing the right thing for 5 or 10 years out, which is, I think, and I'm not trying to pick on developers. I mean, I've been understanding how this works. The fact is they got a job. They got books, they got articles, they got deadlines, and they just sort of hear rumors of security. Oh, the security guys say you got to do this thing. They say, yeah, I'll get around to it someday. And by the time they get around to it, it's way out of date.
They've already hacked the next best thing.
Of course, they have. That's why I can see that's the way I am with everything that's not interesting to me. Like I watch TV shows that are 10 years old because I just can't be bothered. I don't even want to hear it until it's all on Netflix or all on Amazon. It's the thing you don't care about, you just let it slide. Anyway, so here's the defense. The first defense against this was called frame busting, which became pretty popular. People would add some code to the page to make sure that nobody's putting an iframe on top of the frame. So what you do is you put in something like this. You have your script, and then you say if the top location is not equal to self location, then set the top location equal to self location. That makes sure that the frame on top has the same URL as the URL in the bar of the browser. That's the idea here, and that would seem to solve this problem and make sure that the frame I think should be on top is really on top. This turns out to be very easy to circumvent, and in 2010 Stanford showed that 100% of all the frame busting defenses can totally be circumvented. And the problem here is you can't trust any of this stuff. There's some cute solutions to rust around this. One thing you can do, you can redefine top location. So an exception occurs with code like this. You set location equal to something. Now top.location doesn't exist, so now it can't do the comparison. And like we saw last night, JavaScript does goofy things when you compare two things that are not the same variable type. Often the result is true. You can also hook this event, window on before unload event, so an event handler runs, so when the frame busting code detects that the wrong window is on top, and then it tries to set the new location, you've added another bit of code that runs during that process to put it back to the wrong one again. The problem is everything is definable by the developer. You can overwrite these JavaScript functions with other JavaScript functions, so when you think you're doing something, you could be doing Trojan code that's doing something different. In a way, JavaScript has its own version of the UI reader. You call the name of a script of a function, but someone else has overwritten the name with something else. So you can hook that. That's the game here. All right.
Basically overloading a function with your own good stuff.
Yes, that's a pretty good trick. Works very well with JavaScript.
Yeah.
This is like in Windows, you do it at the operating system level with DIL hijacking, where you would load another library on top of the old library, replacing it. And now when people think they're calling a function, they're actually calling a different function.
You put it lower in the path so it happens, so it finds it first.
Yeah, that's right. They also do companion Trojans. Companion Trojans are a really old attack where when someone types start run CMD, you put another cmd.exe in a different folder than where the real one is, like C Windows System 32. You put one in like your home folder, and it will run that one because it finds it first. And now you have run something that's not what you thought you were running. So another thing you can do is define a variable called sandbox. And what that does is disable scripting in the child frame. So the JavaScript to reload the child frame will not run, but it will not stop the page. Cookies will continue to be enabled. This, of course, is the fundamental problem with JavaScript. You can just turn it off. And so here's another one. You can use the IE cross-site scripting filter to disable the frame busting script by including a parameter so that the attempt to reload the top page is misunderstood as an XSS attack by the browser and blocked. This is very much like mucus. We were talking last night about the difference between intrusion detection systems and intrusion prevention systems. And intrusion prevention systems are not terribly common because they have this problem. All I have to do is send a fake attack and your IPS will start blocking it. So if I send attack traffic with a forged IP address equal to your real customers, I can create a denial of service. And Snort was the original IDS, and the hacking tool was Mucus, which sends things that will set off Snort and cause it to block the traffic. And so you can do the same thing here. I can carefully choose a parameter that makes your legitimate JavaScript action look suspicious so the script filter will block it. All right, so the better way to do this, and this is the way things usually go. First, you try to do it using JavaScript to protect you from JavaScript attacks, which is kind of doomed, as you might imagine. And then you switch to adding another header to the browser. Now, this is the modern solution to almost everything, is to add another header in the request. So now you can say X-frame options, and if you do this, it's illegal to load this page in a frame. So you take something valuable like the Amazon buy page and the Facebook login page, and you put this header in there, and now nobody can load that in a frame. And therefore, they can't load an invisible version of that in a frame in front of some other buttons, so they can't trick you into whether you're clicking on it or not. That's the idea. There may be some way around that, but that's the current best way to do this that people know of. Now, another issue is mobile pages. This is the new hotness. Everyone has to do everything on their phone, but your phone is really small, so everything is miniaturized, and a lot of features are missing from the phone, like the URL bar. So, in general, people think clickjacking attacks are not likely to actually work on a mobile device, although I imagine there are some. But people use the mobile page in normal browsers. You can usually load the mobile page anytime you want by just putting m.google.com or something in your browser. And even though your users don't do that, you can use that page for your clickjacking attack because you're going to load an invisible version of it. So I can load the mobile version of Google and put it on top of some other page. So it's an issue, and this I think is why apps are so important. The apps have opened up APIs, and they're doing calls to load the data, and they're often not securing that properly, and you can attack them from a system other than the phone. So you've expanded your attack surface by having multiple versions of everything on the server. There was another news article just last week showing, I think, something like a major healthcare provider, their API intended for the mobile provider just handed out all the data with no authentication, so you could just pump everything out. That kind of thing keeps happening because the developers think it's okay because it can only come from their app. And they don't think about the fact that that traffic did not include a token to verify that it really came from my app, so somebody could reverse engineer it and send that traffic so my server thinks it came from the app when it didn't. So if you want to capture data across domains, like you want to capture an anti-CSRF token from Amazon or something, then the same origin policy is there to prevent this, to stop you from being able to run script on evil.com that can fetch data from amazon.com. But there are, of course, ways to do it. And here we get the stuff we were doing last time even more. You can remove code from pages. And I remember I learned this when I first learned to make web pages, my HTML class. I thought it was funny when I was making new pages, if you forget one quote, the whole page goes blank. And I'm like, what happened? But the whole page is now inside a quote. So you can inject a quote and wipe out a large part of the page. So here, if you can inject stuff up here, but you can't inject script tags, but you can inject something up here, and down here is a form, and you want this token. This is the hidden field that is used, that makes it possible to do these attacks. So I want that token. Well, all I have to do is inject something up here that starts a container and doesn't complete it, and all the stuff below it will be inside there. So here's one of the things I can do. I can start an image URL going to my server and not close the quote, and all the rest of this junk will now go up to my server as part of that image request. It'll be in my server log. So now I got that magic token here. So now I can forge a request cross-site that will be accepted because it'll believe it came from a real browser run by a real user. So this is very much like the code injection attacks we did at the beginning of the exploit development class, where you were doing things like exploiting a ping form. If it comes from the fundamental illogic of I'm putting in stuff that's supposed to be like email subjects or usernames, it's then put in something which is parsed. It's to try to match opening and closing tags, which really makes no sense. In SQL injection, the solution is parameterized queries, where you specify, here comes the data goes in a data object. It is not put in a line of text, which is then parsed, looking for a matching quote. It is put in a thing called the data object with a name, which cannot be misunderstood as a code object, but that defense is not available here. And that's part of why the web remains so very vulnerable. We're using this very unsafe plan of parsing stuff, and especially browsers, and for that matter, servers, take the same file and parse it 2 or 3 times, looking for different languages in the same file. First you look for PHP, you look for server-side includes, you look for ASP objects, you look for Cold Fusion, then you look for HTML, then you look for JavaScript, and each line is read by each of these parsers and interpreted differently. So it's just asking for it to find a way to trick it into misunderstanding some portion of it. Anyway, so that's the injection. That'll expose the token. Here's another one. I can inject a complete form tag. Now, if you have open a form tag, and then you open another form tag, and then you have a submit button, what the browser does is it interprets the submit button as applying to the first form tag, not the second. So I can nullify the form tag that the developer put there and override it with my form tag, so when they click submit, they're sending it to me instead of to who they thought they were sending it to. That's pretty handy. This is close to HTTP response splitting, we talked about before, where if I can inject something that goes in the header, I can put a whole fake HTTP response inside the response. So now your browser gets 2 HTTP responses. And typically your browser will just take the first one, put it on the page, and ignore all that extra data. So I can take the page you were going to get, shove it down out of the way, and put another page so you get some response I wrote, not the page the developer wrote. You can inject CSS. So suppose, again, I cannot put up less than or greater than, but I can put text in the subject line of an email. I can put in this stuff, which will start CSS, with this curly brace, specifying the font family. Now what I should have here is something like Arial or Times New Roman, but again I start with a quote and I don't finish it. So now all the page, down to I think a semicolon or something, will be included in the font family, including of course this token. Large blocks of the code will now be interpreted as the font family. And I have to take the response, include it in another page as a style sheet, and then use JavaScript to query to see what my font is. And my font will be this garbage, including the token. That's interesting. I guess the author said so much into web development he does it this way. My thought would be to just look at the server log or seal the package in Wireshark and look at them, but that's a real low-level thinker. Sealing it with JavaScript is the way a web developer would do it. Then there's JavaScript hijacking. We touched on this earlier. You typically have pages that load JavaScript from an external file, CSS from an external file, and then render your page. So that's fine, but Ajax uses these little requests going up to the server, loading a little bit of code at a time. And the problem is, so you do something like this. You click Show My Profile. I don't anymore redirect to a page called profile.html that contains your profile. Instead, I dynamically load this script. It loads something called Your Details JSON from the server, and that makes this function call, show user info with all this information. So that's how it's done. Now, what I do is I make a page that loads the same script, but defines a different show user info. So it defines another function to overwrite the first function. And if the login viewer views the malicious page, it will then attempt to run this function, and I've been able to overwrite the function with the malicious function, so it sends it to me instead of the other person. This is from the persistence of the function definition, so it can be misinterpreted. And I think ultimately this comes, I don't know enough about JavaScript to say exactly why, but what I'm seeing a problem here is scope. In C, you have global variables and local variables, and you know where they are. In JavaScript, I think this is sort of fuzzy. Like it is, like these high level, like the variable types are fuzzy, so I can define a function, but then if I define another function with the same name, it's not really 100% clear what that name applies to, and I can confuse it. Anyway, all right, so if you want to prevent all this stuff, remember our main tool here is the anti-CSRF tokens, which are hidden fields. Here's a kind of cute trick. If I load script with a script tag, it will run all the script. But I can load script on my own server with XMLHttp requests, and I'm not allowed to do that from another domain. So if I do that, I can poison the JavaScript so it can't be used by anybody else by putting an infinite loop at the top. Anybody else that tries to load my script will just get a pause, and it won't run. So they'll get bad code, but I can still use the page. I don't know if anybody's really doing that, but it's just kind of cute. I kind of wonder if I couldn't still steal it by just using Wireshark to see the raw stuff coming in before it's executed. I wonder how strong a defense this is. But anyway, it'll certainly stop a certain type of attacker. All right, another thing you can do is only let post requests load the JavaScript. You can do that with HTTP requests, but you can't do it with script tags. Script tags will not load it with post requests. They load it with get requests, so that's another way to do it. I'm just thinking about it. It seems to me like I could defeat that by writing my own browser in Python or something, but maybe not. Anyway, all right, so Flash is another issue. Flash is not gone yet, although it's definitely on the way out. And Flash is, of course, responsible for tons of security problems, so Flash can make cross-domain requests. There is a policy file that controls that called crossdomain.xml that specifies where you're allowed to go. So Macromedia, Adobe, Photoshop, and Acrobat can all talk to each other because Adobe bought all those companies, or they're all parts of Adobe, so this is like Microsoft's cross-forest trusts, where you trust another domain. So if you have a cross-site scripting vulnerability in one domain, it can steal data from another domain, and it is possible for the policy statement to just allow every domain, and some people may choose to do that. All right, and the policy file itself may reveal some information like the related domain names. You can make a custom policy file. This is how you load malicious apps on an iPhone. It's been a big scandal. It's come by 3 or 4 times in the security community. It's one of those things that creates a scandal and nobody ever fixes it. There is the iPhone typically only lets you install apps from the official App Store, but they do have a facility for you to be a company and write custom apps and put them on the phone. And all you have to do is get the user to click. You send them like an email that says, it's time for you to load the company policy. And they have to click something and say, OK. Then they load the company policy file, and now they can load apps from the company server that have not come from the App Store. And so if you can just trick a user into clicking OK on something, you can load any app on the phone. You can write malicious apps. The Apple never gets to see them. They're not in the store. I don't think I'm aware of any large number of people really being compromised in this method, but it is a hole in the Apple security model. And here's a similar one. So I can load a policy file, which will overwrite the other one. And apparently a lot of people think that not posting a cross-domain.xml file will prevent cross-domain access. But what that does is leave them open to people injecting extra cross-domain files, which will take effect. If you want to block it, you have to actually include the file to block it. And Java has a similar issue. Although I think client-side Java, just like client-side Flash, is going the way of the dodo bird. But anyway, Java has no facility for a policy file. And HTML5 increases cross-domain interactions. So now you can use XMLHttp requests to do full two-way interaction if the domains give permissions. What happens is your browser now adds an origin header to requests so it knows where you came from. Remember we talked way back in the first couple lectures about how some people would use the referrer to decide whether you came from the real page. And that's no good because anybody can make a referrer say anything they want. So using a hidden token is the technique recommended here with the anti-CSRF token, but this is an attempt to do it automatically in HTML5. Your browser will automatically add this origin thing to the request. So I suppose they're hoping I can trust this, but it seems to me like I can change that with burp too.
You can generate your own postman.
I would think so. So I mean, this is why I'm not sure what the benefit is. This is like another one very common is caller ID on the telephone. If you call 911, the cops look at the caller ID, then they send the people to go shoot the people in the house, and they really don't know who you are or where you are because that can be forged. It's the same issue. Anyway, the server response can now specify what origins are allowed with this header. Access control allow origin. So this will specify what other domains are allowed to play with my domain. And that is the modern solution to everything. All right. And here's other ones, access control request method, request headers, xping other, and so on. There's various versions of headers you can add to your page, security headers, to limit what's allowed to happen to you. And if you use the right mixture of these, and if you are not subject to a man-in-the-middle attack, which allows the attacker to remove them, then you can prevent the browser from letting these attacks go through. And of course, if you are using HTTPS, then even a man-in-the-middle will not be able to modify these, and that's why this is one of the many reasons why browser manufacturers have had it, and I think by the end of this month, in a week or two, Chrome is going to start marking every HTTP site as unsafe, even if you're not logging in. They've just had it with this nonsense. They say everybody should just be using HTTPS for everything. Because if not, all this stuff is pretty much shot. All right. We're down to the cahoots. So which one of these is clickjacking? That's UI redress. All right. Which one controls flash security? Cross-domain, all right? Which one is the weak defense against clickjacking? That's frame busting. And by the way, I imagine this is why a lot of developers are just 5 years behind, because they know that the first defense is probably useless anyway. So, anyway. All right, that's where you try to use JavaScript to stop the attack, which anybody could have guessed is really not going to last long. All right, so which is the header field that a browser adds to your XML HTTP request? Okay, that's origin, all right? And what's the recommended way to stop clickjacking? All right, that's X-frame options, and I think the next one, no, okay, good. So what's the way to steal a token with HTML injection? It added another form tag to overwrite the first one. All right. So John E times 2 Ward F. I just want to mention the schedule. We're almost to the end of everything here. This class, there's only one more lecture for next week, and that's it. We're going to do the second half of this chapter, and that'll be the end of it. There's no class the next 2 weeks, and then there's the final. So this class is about over. There are a lot of special events coming up. This Tuesday, 6 days from today, is the job fair. If you need a job, you should go to that. We have a new bunch of employers that were not at the previous one. They are not all going to be there physically, but they all have jobs. Some of them told us what they want. We're going to be like picking resumes. We need guys with CCNA or whatever. Then a lot of visitors are coming. Thursday I got a visitor, and May 3rd I got Kyle Rankin, and May 8th we got Jakub Sandor. So a lot of people are coming. These are worth extra credit. You can learn from these guys also. Among other things, you can learn from them about jobs. So, anybody got any questions? I'm going to clean up, and I'll take a look in the lab and see what's happening up there. Other than that, I won't see you till next week, unless you're taking some other class.